Welcome you all for the yet another episode on petroleum refining. In the previous two episodes, we have discussed about the various refining activities known as primary processing and secondary processing, wherein the crude oil is converted into valuable petroleum products. Today, we are going to talk about the peripheral units known as utilities and offsite facilities. What are the things that would be covered in today's episode? Today we will talk about storage and handling facilities, power and utilities. Under utilities we will cover many things. Then finally HSE related systems. That is what we are going to discuss today. First, let's try to understand about the storage and handling facility. Geographically, if you see a refinery, 3/4 of the refinery will be occupied by the tank farm. Tank farm is a place where different storage tanks are located. And what for these tanks are located? These tanks are primarily to store crude oil, to store and feed intermediate products, then finally to store and then transfer finished products and the other chemicals which are used during the refining process. So when we talk about the storage tanks, there are primarily two types of storage tanks. One is fixed roof or cone roof. The second one is known as floating roof. In a fixed roof tank, it is an ordinary tank where you have a cylindrical shell and then you have a conical roof along with the vent. Whenever product is received in the storage tanks, the level will go up. Always the hydrocarbon vapor will be on the top of the liquid surface, and these hydrocarbon vapors, they go out and then air will come in during the pumping in and pumping out operations. So during the entire process, there is a small quantity of hydrocarbon going out as evaporation loss. So this kind of tanks are primarily meant for non-volatile products known as finished lube oil or fuel oil, primarily heavy oils. So if I use a cone roof tank or fixed roof tank for a lighter hydrocarbon, there is always a possibility of the vapors going out continuously and there is a huge evaporation loss. In order to address the evaporation loss, the designers have come out with another type of tank known as floating roof tank. In the floating roof tank, the roof is floating on the surface of the liquid and it is not tightly fixed or welded with the tank shell. So the roof can float up whenever the liquid level goes up. The roof can come down whenever the liquid level comes down. So this way there is no gap between the roof surface and the liquid surface. So this is how the evaporation is minimized. So floating roof tanks are primarily used for storing naphtha, heavy naphtha, kerosene, aviation turbine fuel, diesel, etc. So these kind of light products which are evaporative in nature can be stored in floating roof tank. Then we have other type of storages which are known as pressurized storages. For example, if you take LPG as a product from refinery, LPG is actually a gas. It is liquefied and it is liquefied under pressure. So if I have to store this LPG, I cannot store it in a normal tank. I have to store in a pressurized container. So that is where we try to use a bullet or a spear. Bullet is almost like a capsule kind of a structure, whereas spear is spherical in shape. Because of the geometry of this kind of tanks, it can withstand the pressure from all direction. So these are all little costly to construct and little costly to maintain, but definitely we have no other go to store products like LPG, butylene, propylene kind of products. Then in a tank, what are the different kind of activities happen in a refinery? So for example, if you take crude oil, the crude oil can be received in the tank. So the receipt is one kind of activity. Suppose if it is an intermediate storage tank, the intermediate products are received from the processing unit, or a tank can be meant for finished products. The finished products are received. So receipt is one function. Then certain tanks, we have to remove water. If it is a product, water cannot be taken to market. So the water need to be settled down and then it has to be drained. If it is a crude tank, again water need to be settled down and then drained, because water cannot be pumped into the distillation unit. So water removal or preparation of the tank is another activity. Then the third set of activity that can happen in a tank is blending. So for example, you may have a diesel. So diesel would be a mixture of a raw diesel, kerosene and heavy naphtha. So all this can happen through in a pipeline. If it is happening in a pipeline, then it is known as pipeline blending. If it is happening in a tank, it is a tank blending. So blending can be another activity. Then for the final activity that is happening in a storage tank is product dispatch. So the finished product will be sampled and certified by the quality control laboratory, and once a batch number is given, then it will be taken to market. So these are all part of offsite facilities in a refinery. Now let's try to understand the power and utilities. So power and utilities will be a separate department in a refinery. Of course, it is part of operations, but it is not a part of the manufacturing block. So under utilities, we have water treatment plant, steam generation, cooling water system, process water system, service water system, power generation, instrument air system, plant air system, inert gas or nitrogen system, and finally fuel system. So these are all the different kind of utilities that are provided in a refinery. So primarily utility is nothing but an essential commodity or essential system without which the refinery cannot function. So it is imperative that we need to know more about the offsite and utility, because they are the vital for running a refinery without any interruption. Water treatment plant. So water is an essential commodity to run a refinery. So this water, the sources for the water would be either groundwater, river water, or sea water, or city sewage water, or a combination of all this. So here the water need to be, first of all, water need to be sampled, and water need to be analyzed for its hardness content or softness content, and it has to be analyzed for all other composition. So based on that, the treatment will be decided. So the treatment plant will be designed upfront based on the raw water quality. So primarily here we try to soften the water, because the hard water will form scaling inside the refinery equipments. It has to be softened, and it has to be deaerated. All the dissolved gases from the water need to be removed. It can be either oxygen or carbon dioxide. Then finally you have to remove all the minerals. So this is very much essential to produce steam in a boiler. In order to produce steam in a boiler, we have to have demineralized water. So the removing of the minerals using ion exchange is one step in the water treatment plant. This is an essential step in a refinery utilities. Then steam generation. Why do we need steam? Steam is meant for multiple purposes. One is, even in process in a refinery, like the steam reformer, you need the process steam. The process steam will be part of your process. So here are the steam and hydrocarbons in a reformer. So they undergo chemical reaction, and finally hydrogen is produced. Then steam is also used in steam turbine to produce power. Sometimes steam is also used as a turbine for driving the different kind of pumps. What are the steps involved at a high level? The heating of the demineralized water is happening in the boiler coil by burning fuel oil or fuel gas, and the steam is generated, and then the steam is segregated into different stages. For example, based on the pressure, the steam can be categorized into high pressure steam, medium pressure steam, or low pressure steam. The next one is known as the cooling water system. I think in one of the previous episodes we have discussed about how the crude oil is preheated before getting into the furnace. So, crude oil is preheated with the help of the hot products. So, here we have twin objectives. One is to increase the temperature of the crude oil so that the furnace load can be minimized. Number 2 is we have to reduce the temperature of the products from the distillation column so that it can be safely stored in the storage tanks. So, this is the kind of heat exchange happening. Apart from these heat exchangers, finally there will also be product coolers. The product coolers will ensure that the products reach at ambient temperature before they are sent into storage. How are these products getting cooled? They are cooled in a water cooled exchanger. So, what would happen to the temperature of the cooling water? The temperature of the cooling water will go up. So, the hot cooling water coming back to the power and utilities department, now it has to be cool. The quantum of cooling water coming back to the cooling section will be enormous. So, in order to cool that, we have a huge arrangement known as cooling water system. In many places, hydrocarbons need to be cooled using water, and the water getting heated and the heat exchangers need to be cooled, and this is happening in the cooling tower or cooling water system. So, the cooling water system primarily consists of a cooling tower, and it can have multiple towers based on the load and throughput. Then we have huge water pumps which will pump the cooling water to entire refinery to all the coolers, and then again they will come back to the system, the cooling water pipeline network. So, all this will be part of cooling water system. Then we have process water. There are places where water needs to be injected at different stages of petroleum refining. For example, before admitting the crude oil into the atmospheric distillation column, salt present in the crude oil need to be removed. So, how it is done? Again, we have discussed earlier, the controlled quantity of water is added and sent to a vessel known as a desalter, and that is where the water is allowed to settle down. So, for admitting such kind of water into process system, we need to have process water. Process water should be clear, colorless, and free from iron, manganese, hydrogen sulfide, and other organic growth causing substances. So, that is known as a process water system. Then we have yet another type of water system which is known as service water system. So, here inside a refinery, a lot of maintenance activities will be happening, or during that process the entire flooring will be spilled with the oil and water, and they need to be washed. So, for all washing purpose we need service water. Water for product washing may need to be equivalent to drinking water or a higher quality, whereas water for general refinery cleanup may be much lower in quality. So, it is primarily meant for service purpose, cleaning and other housekeeping activities. Sanitary and service water may also vary in quality. Water used in water houses may be of lower quality than for drinking purpose, which is known as potable water. Then power generation is an important activity in a refinery, because in refinery there will be lot of rotating equipments that may require power supply, electrical power supply. Since a refinery is a continuous process unit which runs 24/7 and 365 days in a year, almost for 3 to 4 years until the turnaround maintenance, the power supply need to be very much reliable. So, the generally refineries do not rely on external power supply. In order to have a reliable system, they have a captive power generation unit inside the refinery. We mentioned about the need for steam generation facility. So, with the help of the steam generated, we can run a turbine and with the help of the turbine we can produce power. A refinery cannot afford to rely on external power supply if it is not reliable, as refineries need to run continuously. A captive power plant is mandatory for most of the refineries. Power is produced either by running a steam turbine or a gas turbine. Excess power, if at all, if it is generated from a refinery, that can be sold to the external grid. And normally the refinery will be floating with an external grid, which means normally they will be selling power, but in case of an emergency they can start consuming power from the grid. Then instrument air system. In a refinery you have lot of instrumentation. So instrumentation range from the sensor, dial gauges, etc. But finally all these instruments are meant for regulating the flow of some process stream, fuel or steam, etc. To regulate all this process stream you need to have a control valve, and to regulate the control valve we need instrument air system. So though all the instruments are operated by electronic signal, the final control elements, that is the control valves, generally operate by pneumatic air. So in order to supply pneumatic air to the control valve, we need to have a centralized facility which is known as instrument air system. The instrument air is made available by ensuring the limits for dew point, particle level and contaminants and lubricants as per design. So this instrument air is generated and then sent throughout the refinery in the instrument air network, and this network should be maintained with the proper pressure. Then we have plant air system. So in the previous episode we mentioned about bitumen air blowing, where we need air as a process stream. So that is why we have a compressed air system or plant air system. There are certain plants in a refinery where air is used as a process stream, and this air shall be void of moisture and any other impurities, because it is directly mixing along with the hydrocarbons. Then we have inert gas system. So the purpose of inert gas system is to test every segment of the refinery before we do the startup. So after a turnaround maintenance, a refinery has to be started at that point of time. When we start pressurizing the entire system, there should not be any pressure leak, and the hydrocarbon should not come out and create a safety hazard. In order to take care of these kind of issues, we test the entire system with the help of inert gas. In a refinery, nitrogen is primarily used as the inert gas. Nitrogen as inert gas may be needed for pressure testing of vessels and the system in the refinery. It is also used during startup of process plants, and nitrogen is produced by splitting the air into oxygen and nitrogen either by pressure swing absorption or cryogenic methods. Then we have fuel system. There are many process heaters or furnace inside a refinery, starting from heating crude oil. There are multiple segments of the units where the temperature of the process stream need to be increased. So this can be done by burning fuel gas or fuel system, and fuel gas and fuel oil are already produced in the refinery, but we need to have a system to regulate their flow, pressure, etc. Fuel gas can come through a fuel gas header. Similarly, fuel oil will also have a fuel oil supply header as well as return header. So if fuel oil is not congealed, the line should not get choked. So that is why we have a fuel oil return header, which will go back to the fuel oil tank storage, so that continuous movement will be there, and there is no possibility of line getting choked. Then we have certain systems which are very much essential from point of view of health, safety and environment. One such system is a flare system, then fire water system, then effluent water system. Let's quickly try to understand all the three systems. In every refinery, from distance you will be able to find out the presence of a refinery, or even sometimes you can find out whether the refinery is running or not. When a refinery is alive, it can be significantly been seen with the help of a flame in the flare stack. What is meant by flare stack? Flare stack is nothing but a tall tower above which the waste gases from the units are burnt safely. If they are not burnt safely, then the hydrocarbon will come and settle down at ground level and it can create a potential safety hazard. So, in order to avoid this, these gases are burnt. And of course, today we have a lot of sophisticated systems are there, that is to compress the flare gas and recover energy from that, which is known as flare gas recovery system. But still there will be a lot of uncontrolled gases which are coming out of the refinery. They are all collected, the hydrocarbons, if any, liquid hydrocarbons, if any present, they are settled and separated, and finally the gases alone will be burnt on the top of the flare stack. Then we have fire water system. So, even in commercial buildings you would have seen the fire water header and then the fire water network. So, in a refinery, since a lot of hydrocarbons are there which are flammable in nature, or sometimes they are also explosive in nature. So, we need to have an exhaustive fire water system. The fire water system primarily consists of a fire water pond. Most of the time the treated water will be stored as the fire water pond. And then we need to have high capacity pumps which are fire water pumps. Then we need to have different peripherals like hydrants, turrets and nozzles, so that at any point of time the water can be properly focused and then targeted on the fire happening place. Then we have certain other systems known as deluge system, water curtains, spray system, etc. Without taking much time, by blowing a seal, so all of a sudden if there is a fire in a vulnerable area, immediately the water should form as a curtain or a shower. So, those kind of safety mechanisms, pipeline network along with the interlocks logics are made available as fire water system. Then we have effluent water system. So, refinery generate lot of effluent. Whenever a vessel is opened for maintenance, the content will be drained, or when a floor wash is happening, all the water and oil particles they go and get accumulated in the sewer basin. From the sewer basin, the oil is allowed to float on the top of the sewer, and finally they are pumped off and then circulated back into the system. The rest of the water from the sewer basin will go to a treatment plant where you have primary treatment, secondary treatment and tertiary treatment. So, after treatment with the chemicals, and there are refineries which also employ a reverse osmosis plant. When you have reverse osmosis plant, you will be able to recover as much water as possible, and the water can be circulated back. So, number one is you have internally you can manage your water requirements, the water consumption can be drastically reduced. So, these are all part of the refinery water treatment system. So, today in the offsite and utilities segment, we have seen what are all the categories, what are all the different type of systems that is part of offsite and utilities. The functioning of the offsite facilities are often as critical as the process team. So, like the process unit, the functions of the offsite facilities also happen in a 24/7 basis. They are so critical. Most of the utilities or offsite facilities are operate in an uninterrupted manner like the process plants. So, at a very high level, we quickly discussed about the offsite facilities and utilities which are very much essential for smooth operation of the refinery. So, every engineer who would like to know more about refining, they must know about offsites and utilities. So, with that we conclude today's session. Thank you so much. Let's catch up with yet another episode on petroleum refining. Thank you so much.